Alright, hello everybody. Today we're going to be looking at lesson 4.5 called Are There Other Congruent Shortcuts? This is really a continuation of the stuff we did in 4.4 where we talked about those possible shortcuts. And so in today's video we're going to recall those possible shortcuts we can use, define and use the reflexive property, and also practice our side, 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 and our side, angle, side conjecture. By the end of the video, you should be able to complete and understand 2 of the 2 formal proofs that we're going to do. And I'm going to ask 5 questions at the end, and you should be able to get 4 out of the 5 questions correct. If you're still having problems with that, maybe you want to ask me for some extra help, try some of those old problems, or go back in your book and try some of those also. If you're presenting in class, I would suggest that you are, we have 2 new vocabulary words. Use those, define those for us, and then also asking us questions. So don't just steal my examples, come up with your own, maybe use some of those from our practice that we did, and go over those 4.4 conjectures that we learned. All right, so let's review quick. In class, in 4.4, we looked at 3 of our 6 possible conjectures. We looked at side, 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 angle, side, and side, side, angle. When we did that, we found out that side, 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 and side, angle, side, when we were given those 2 things, we could construct two congruent triangles. But when we tried side, side, angle, we got a bunch of different triangles. And so right now we know 2 of our 6 possible shortcuts are going to work. We know side, 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 and side, angle, side. Next class, we'll look at those other 3. We'll look at angle, side, angle, angle, and also our angle, angle, angle. All right. So next class, like I said, side, angle, side. And for this one, this is where our new vocabulary word comes in. It's called the included side. So an included side is when it is between 2 angles of a triangle. So in the diagram, we can see they've given us 2 angles, and then that included side is that side that's in between the 2 angles. That just makes it easier for us to talk about the side in the side, angle, side conjecture. We'll also look at side, angle, angle, and then lastly our angle, angle, angle. All right. And then when we briefly talked about in class, but just another one for you to be aware of, this is our other vocabulary word, it's the reflexive property. So the reflexive property, what it says is basically something is congruent to itself. And so it's written as A is congruent to A, which makes sense, but when we're writing some formal proofs like we're about to do, it's going to be really important that we can say something's congruent to itself. So times when this is going to come in handy is when we're using our side, 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 or our side, angle, side conjecture. And it's going to be helpful when the 2 triangles share the same side. So a time when it won't be helpful, our non-example, is if I give you 2 different triangles that don't touch at all. If they don't touch at all, the reflexive property isn't going to be of any help to us. If you look to the right, I've got 2 examples, one using our side, angle, side, and our side, side, side where it's going to help. So in this picture, we know a side by our notation marks, and we know angle. If we want to say something is congruent by side, angle, side, we're going to need to figure out another side that's congruent. And you can see that these 2 triangles share the same hypotenuse. And so that side is congruent to itself. And that's what the reflexive property says, is that that side is equal to that side. In the bottom, when we're using our side, side, side conjecture, we can see we've got those 2 sides that are congruent to each other, and then that 3rd side that they share. And that 3rd side is congruent to itself, and that's where that reflexive property is going to come in handy. We'll try some formal proofs next. And so we'll be using the reflexive property. So we'll be looking for those in the examples we're going to try. All right, so we're moving on to our formal proofs. This is where some information is given, and they're asking us to prove something. So we're going to make a bunch of statements with what we know, and try and say that what we want to prove is that triangle EGF is congruent to HFG. Right now, I would tell you to pause the video, write down this information, and try and see if you can come up with it. This first one might be a little difficult, so maybe watch me do this one, and then try the second one by yourself. So the first thing we're going to do is we're going to write down everything that we know. I know that side EG is congruent to side HF. It's shown in our picture, and it's also told to us that's given information. So my reason is that it's given. Another piece of the puzzle that's given is that line L is parallel to line F. And that again is given. All right. So we're trying to prove that those two triangles are congruent. I have one side already. I know that side EG is congruent to HF. So I'm either going to use my side angle side or my side because those are the only two I know how to use right now. Hence, we've got parallel lines. And we know lots of things when we have parallel lines about the angles. So when I have two sides being cut by a transversal, I've got my parallel lines, and I've got that transversal. So I know that angle EGF is going to be congruent to angle GFH because they're alternate interior angles. So I'm going to say that. I'm going to say that angle EGF is congruent to angle GFH because they are alternate interior angles. I have abbreviated alternate interior.
Boys swim team, your bus is here. Boys swim team, your bus is here.
So we know a side, we know an angle, so the thing we need next is a side. Here's where that reflexive property is going to come in handy. We've got those two triangles. We've got triangle EGF, and we want to say that it's congruent to HFG. You can see that these two triangles share a side. They share side FG. So I'm going to say that FG is congruent to FG, and my reason is just going to be the reflexive property. Now, I can say that those two triangles, what we wanted to prove originally, are congruent to each other using that new conjecture that we know, that we learned in class today. These two triangles are congruent by side, angle, side. So in our formal proof, we started out with some given information, and then based on the diagram, we were able to make some conjectures like that, or some statements, sorry, that the angles and those sides were congruent to each other, and it fell in our side angle side category, so we could say that those two triangles are congruent to each other. All the sides and all the angles of those triangles are going to be congruent to their corresponding parts. And that's what our formal proof looks like. All right, so let's try one more. We've got some given information and something we want to prove. I want to prove that triangle RQP is congruent to triangle SQP. So we have some things that we know, and based on what we know and what we can see in that picture, let's see if we can prove that those triangles are congruent. So this is definitely one you're going to want to try by yourself. Put the video on pause and try this one, and then you can check yours against mine. All right, I'm going to start solving it. So first thing I'm going to want to do is I'm going to want to state my given information. I'm going to state it line by line that QR is congruent to QS. So the easiest step is just stating what we already know and looking at it in our picture. Here our notation's been provided for us. If it hadn't been, I would have added it in. All right, and we also know that QP is going to bisect the angle RQS. So in the picture, we have a ray bisecting an angle. What we know, oh, I'm sorry, that information is given. What we know about angle bisectors is when something is bisected, it's cut into two equal parts. So we know that these two angles are going to be congruent to one another. So we can state that our QP is congruent to angle PQS, and then we state what an angle bisector does. So reason is because angle bisectors make two congruent angles. All right. So we've got a side, an angle, and the thing we're going to need next is the other side. Those two triangles share side PQ. So I know that PQ is congruent to PQ by our reflexive property. Because I know that the triangles have congruent sides, angle sides, I can say that these triangles are congruent to each other. So RQP is now congruent to SQP by our conjecture side, angle, side. These come with practice, so please make sure you're trying them as we go through them. All right, so now I'm going to ask you 5 questions, and I want you to be able to answer all 5. Remember, you want to get 4 out of 5 correct. So the first one is one of the practice problems, comes straight from the worksheet that we did in class. It says that M is the midpoint of AB and PQ. So what triangle is APM congruent to? Take a minute, pause the video, maybe make a copy of the diagram, and try that problem out. What triangle is congruent to APM? In number 2, we have KIT is a kite with KI congruent to TI. And again, I want to know what triangle is congruent to triangle KIE. Again, copy this picture, write down what you know, and figure out that congruent triangle. In number 3, same thing, except this time we just have the picture and the notation marks to go on. We're trying to figure out what triangle is congruent to MO and N. And in number 4 and number 5, I want you to name each possible shortcut just by looking at the picture. So what shortcut are they suggesting we try, and if it works? So there's 3 that we did in class in 4.4. So for those, I want you to say if you know if it works or not, and the ones we haven't tried, just say you don't know. Put a question mark. Still unsure. We'll figure that one out in class. But in these 3 pictures, try to identify the shortcut they want us to use. Copy these down, and then you'll be doing the same thing in number 5. The pictures are just different. Copy those down and see if you can identify the shortcut they want us to use and whether or not it works. All right, and then I'll go back and I'll provide us with the answers. So I'm going to go back to number 1. What triangle is it congruent to? Well, they say that M is the midpoint of AB. What we know about midpoints is that it cuts that segment AB into 2 equal parts, and M is also the midpoint of PQ. So we have 2 sides, and then the other thing we have to look at in the picture is we notice that we have vertical angles. When you have vertical angles, we can now say that these two triangles are congruent by side, angle, side. And the order we place our letters is going to be really important. And so it wasn't just seeing that it was the other triangle, but putting those letters in the correct order. So make sure your letters are in the correct order. We want to go from A to P. If you look, AP doesn't have any notation marks on it. So we need the side and the other triangle that doesn't have any notation marks on it. That's either going to be BQ or QB. It's all going to depend on where we go from there. So after we go AP, we need to go P to F. That's the set of our triangle with those two notation marks. So I need to go BQ, QF. So I'm going to say it's congruent to triangle BQF. And again, the order of those letters is really important. So make sure that you have triangle APM is congruent to triangle BQF. In number 2, they tell us we have a kite with KI congruent to TI. One of the things we know about a kite, we have to think about the properties of a kite, and we also know that KE is congruent to TE. And then IE, they share that side, so that would be congruent by the reflexive property. So we know that these two triangles are congruent by side, side, side. So again, we want to make sure we get our letters in the right order. So we say KI, that's the side that hits that one notation mark. So we're looking at either TI or IT. The next side is the side they share, which is IE. So I need KIE is congruent to IT. In number 3, we just have the picture. So we have parallel lines. We want to pick up that by the notation. When they show you parallel lines, that's a good hint that you're probably going to have some angles that are congruent. So look for those transversals. In this picture, NO is our transversal. And we can say that these two angles here are congruent. And then that side they share, that's also our transversal, NO. They share that side, so it's going to be congruent by the reflexive property. So we have it by the side angle side. And so we want to look for that proper order. MON is going to be congruent to TNO. And then in number 4 and 5, we want to identify the possible shortcut. This first one is side, side, side. And we know that, yes, it does work. In my next one, I have a side, and then an angle. That one we talked about in class, and that one does not work. Next one, we have side, angle, side. And we don't know if that one works or not. And then in number 5, just continuing it, we have angle, angle, angle. We don't know about that one yet. Next we have angle, side, angle. We have not talked about that one either. And then our last one, this one is side, angle, angle, which we have not discussed. Oops. Sorry. In number 4, we did talk about side, angle, side, and we found out that yes, that one does work. So in number 4, those are all ones we talked about in 4.4 that you should know if they work or not. And then in number 5, ones we have not talked about yet, and we're not sure if they work. All right, hopefully you were able to get 4 out of the 5 correct. If not, go back, try some more problems. All right, have a good night, everybody.